Myself, Dr. Somit De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities. This is my lecture number 3 under module 3, topic vector space. Paper name Mathematics 1A. Paper code BSM-101, branch computer science. And in my last video, I had discussed linearly independent, linearly dependent, and if one set of vector is given, how to check whether it is a linearly independent or not. Okay, so this is the continuation of the last lecture, and here I will discuss the new thing like basis and how to find the dimension of a basis. Okay, now so that the vector 2 6 minus 1 8 0 10 4 3 0 0 minus 1 4 0 0 0 8 are linearly independent in the four-dimensional vector space RQ. So this type of question says that the four-dimensional point. Similarly, the four-dimensional alpha is equals to first vector, that is 2 6 minus 1 8, and beta is equals to 0 10 4 3, and gamma 0 0 minus 1 4, delta is equals to 0 0 0 8. So if I already know, if I can express as a linear combination like A alpha plus B beta plus C gamma plus D delta, where A alpha plus B beta is A, B, C are a scalar. So we can write A alpha plus B beta plus C gamma plus D delta is equals to null vector, where A, B, C are four scalar. Okay. So if I take A alpha 2 6 minus 1 8, B 0 A 10 4 3, C 0 0 minus 1 4, D 0 0 0 8. Okay. So if I simplify, what we get, 2A comma 6A plus 10B comma minus A plus 4B minus C, 8A plus 3B plus 4C plus 8B is equals to 0 0 0. So there are four components. This is also four components. If I compare point by point, that is 2A is equals to 0, to 6A plus 10B equals to 0, minus A plus 4B minus C equals to 0, 8A plus 3B plus 4C minus 8 equals to 0. So from equation number, from here, A is equals to how much? A is equals to 0. If I substitute here, A is equals to 0, P is equals to 0. If I substitute the A and B value in third, I will get C is equals to 0. If I put A is equals to 0, B is equals to 0, C equals to 0 in this fourth relation, then we will get D is equals to 0. So from here it is clear, from this set of equation, we get the value of A equals to 0, B is equals to 0, C is equals to 0, is equals to 0. Okay, so this is the only one solution of this set of system of equation. So that's why, so from here it is clear, all scalar are 0. So that's why the given set of vector forms a set of linearly independent vector. So already you know, if the if all scalar are 0, then only we can say linearly independent. If any of if at least one of the scalar is non-zero, at least one is non-zero, then we can say the set of vector is linearly dependent. Now question number, now next, so that the four vector 1 0 0 0 1 0 0 0 1 and 1 1 1 for linearly dependent set of vector, but any three of them are linearly dependent. Let's see. Here four vector of RQ are alpha 1 0 0, beta 0 1 0, and gamma 0 0 1, and delta 1 1 0. Clear? Just like previous. So here is a three-dimensional problem, and last one is a four-dimensional problem. Just to check, for four constant, so we can express A alpha plus B beta plus C gamma plus D delta is equals to 0 0 0, because this is a three-dimensional point. So now you substitute the value alpha, beta, gamma, and delta to this relation. That what we get, A 1 0 0, A plus B into 0 1 0 plus C into 0 0 1, and D into 1 1 1 is equals to, if I simplify, what we get, A plus D comma B plus D comma C plus D is equals to 0 0 0. After simplification, what we get, A plus D equals to 0, B plus D is equals to 0, C plus D is equals to 0. Okay, so for there are four unknown, three equations. So from here it is clear from the Gauss elimination method. So if the number of variable is higher compared to the number of equation, then we can express one variable in terms of other, so that means we can't prove that all A, B, C are 0. So since the system is equation, there are three equations, four variables. So the system equation has non-zero solution. That is, A is equals to minus B is equals to D is equals to minus C is equals to C1. Say C1 is a scalar. So therefore the set of vector alpha beta is linearly dependent. So already you know if all are non-zero. So we can say by Gauss elimination method, so that means all scalar are not zero, so that's why the set of vector alpha, beta, gamma, delta is linearly dependent. Okay, yeah, but linearly dependent. If we eliminate a linear, if equate the linear combination any three vector alpha, beta, gamma, and delta equal to the null vector, then it is easy to show that all the component constant are zero. Hence, we can claim that any three vector from alpha, beta form a linearly dependent set of vector. But if we equate linear combination of any three vector alpha, beta, gamma, and delta equal to the null vector, then it is very easy. That is, we can consider this A alpha plus B beta plus C gamma equal to 0, 0, 0. So just like the previous question. Okay, and linearly any three vector, that is it's all well known example 1 0 0 0 1 0 0 0 1. So automatically if you want to prove that this is scale all linearly dependent or not, you can see all scalar become zero. So that's why any set any three vector from alpha beta gamma delta forms a linearly dependent set of vector. We can claim that any three vector form a linearly forms a linearly independent set of vectors. Next. Now basis. Let V be a vector space defined over a field F. Let B be a non-empty subset of V. Then capital V is said to be a basis of V if V contains linearly independent vectors in V and V spans V. What is the meaning? So that means the basically B is a subset of V. So that means V contains some set of vectors. So first you have to prove that your set of vectors B is linearly independent, as well as your set of vector B can express each and every vector of V. That is V span V vector V set of vectors span V. Okay, so if you can prove that these two conditions are satisfied, then only you can say the set B, the set of vectors, the set of vector P is a basis of V. Okay, dimension. Let V be a vector space over a field F and V and capital B be a basis of V. Then the number of distinct vectors, in V. I repeat, I use multicolor for a better understanding. Then the number of distinct vector in V is the dimension of V. Okay. Now try to understand, very easy. So that the set of vector 1 1 0 1 0 1 and 0 1 1 is a basis of the vector space R3. So this type of question you can expect from here. Okay, let alpha 1 1 1 1 1 0 beta 0 1 0 0 1 1 0 1 and gamma 0 1 1 be a three vector of R cube. First we equate the linear combination of alpha beta gamma with null vector. Then we have A alpha plus B beta plus C gamma is equal to 0 0 0, where A B C are three real number. That is, so if we can express For linearly independent, first what we are objective? First linearly independent, then whether it can span or it can span or not. Okay, so first part already you know how to prove linearly independent or dependent. Okay, so that is A alpha, that is 1 0 0 plus B beta, that is 0 0 1 1 0 1, and C gamma, that is C 0 1 1. So after simplification, what we have? A plus B plus A plus C plus B plus C is equals to 0 0 0. That is A plus B equals to 0, A plus C equals to 0, or A B plus C equals to 0. So already you know, if the determinant, there are three unknown, three equations. So by using Kram's rule, if the determinant value is not equals to 0, then we can say the all values of this homogeneous equation, the solution of the homogeneous equation is 0. Okay, so now let's see the coefficient of the determinant. Now, therefore, the equation, if we can compare the coefficient of one, that is A coefficient, that is 1 1 0, that is A 1 1 0, B coefficient 1, there is no B 0 1, and C coefficient, there is no C, that is 0 1 1. So if I simplify, that is 1 0 minus 1 plus 1 into 0 minus 1 plus 0, again minus 2, that is not equals to 0. So therefore the system equation one has a unique solution, that is A, by using Kram's rule. A is equals to 0, B is equals to 0, and C equals to 0. All are 0. So from it is clear, all if all scalars are 0, so that means the set of vectors, that is 1 1 0 1 0 1 0 0 1 1, is linearly independent set of vectors. Correct? Similar set of vectors. Okay, since the set of contains three distinct vectors, so therefore dimension of R cube is equals to 3. So the set of vectors 1 1 1 1 0 and 0 1 0 1 and 0 0 1 1 forms a basis of R cube. First you have to check whether your set of vectors is linearly independent or not. If independent, and three vectors you have, so that means by using these three vectors you can express all each and every vectors of R cube. So that's why then you write down again the say, since the set of contains three distinct vector, that is dimension of R cube is R3. So the set of vector 1 1 0 and 1 0 1 and 0 1 1 forms a basis of R cube. Next question. So same way, so that the set of vector 1 2 2 1 minus 1 2 1 0 1 forms a basis of R cube. Let alpha 1 2 2 beta 1 minus 1 2 gamma 1 0 1 be the three vector of R cube. First equating the linear combination alpha beta gamma with null vector, that is A alpha plus B beta plus C gamma equal to 0, that is 0 0 0, where A B C are all real, just like previous. Same linear combination checking, linear independent or dependent checking, first checking is always same, that is A alpha, that is 1 2 2, B beta, that is B 1 minus 1 2, C gamma, that is 1 0 1 equal to 0 0 0. If I simplify, what we get? A plus B plus C comma 2A minus B and 2A plus 2B plus C equal to 0 0 0. Comparing the position was, what we get? A plus B plus C equal to 0, 2A minus B equal to 0, 2A plus 2B plus C equal to 0. So there are three equations and three variables, that is A, B, C. So same way, now the coefficient of equation number 1 is a determinant. A coefficient is 1 2 2. What is the B coefficient? 1 minus 1 2. What is C coefficient? That is 1. There is no C. That is 1 0 1. There is a minor mistake you have. I have. That is 1 minus 1 into 0. Okay. I typing mistake. That is 1 minus 1. That is 2 into this. And from 1 into 4 minus plus 2. That is 6. 1 into 4 plus 2. So after simplification, what we get? That is plus minus 1 minus 2. That is minus 1 minus 3. That is from here 6. That is 3. Not equals to 0. But using Kram's rule, the system equation 1 has unique solution. A is equals to unique solution. That is unique solution. A is equals to 0. A is equals to 0. B is equals to 0. C equals to 0. So by using Kramers rule, because it's a homogeneous equation, hence the set of vector 1 2 2, 1 minus 1 2, 1 0 1 forms a basis from the set of linearly independent set of vectors. The here this set of vectors contains three different vectors, so that's why dimension of R cube is equals to 3. Hence the set of vector 1 2 2, 1 minus 1 2 and 1 0 1 forms a basis of R cube. Now another question. So last question, whether form a basis or not. Now find the value of x for which the set of vector forms a basis. Let alpha same way. So if they are linearly, first it should be linearly independent. If linearly independent, determinant should be equal to 0. If determinant equal to 0, from this you can find the value of x. Let's see. Let alpha x 1 comma 1 beta 1 2 3 gamma 0 0 1 be three vectors in R cube. Now equating the linear combination of alpha beta gamma with the null vector in R cube, we have a alpha plus b beta plus c gamma equal to 0 0 0. So now we can write alpha value, that is a alpha, that is x11, beta b beta, that is b1 2 3, and c gamma, that is c0 0 1. After simplification, what we get? Ax plus b plus comma a plus 2b comma a plus 3b plus c equal to 0 0 0. So what we get? Comparing both sides, that is ax plus b equal to 0, a plus 2b equal to 0, a plus 3b plus c equal to 0. So now the coefficient of determinant 1 is x11, 1 2 3 and 0 0. There is no c in the first equation, third equation, so 0 0 1. After simplifying, what we have? That is 2x minus 1. If I compare with the resistance, that is ultimate 2x minus 1 determinant value. Thus for 2x minus 1 equals to 0, that is x equals to half. The coefficient of the determinant 1 is 0. Then by the Kramers rule, the system of equation has non-zero solution, which gives the set of vector is linearly dependent. If I put the set of vectors, that is 1 x 1 1 and 1 2 3 and 0 0 1, if the determinant value becomes 0, this set of vector is linearly dependent for x is equals to half. If x not equals to half, so if x equals to half, so if the set of vector is not linearly independent, so that means the set of does not form any set of is form a basis. Okay, so first condition, the set should be a set should be linearly independent. Okay, so and hence for x not equals to 2, if x not equals to 2, then the set of vectors form a linearly independent set of vectors, as well as this x 1 1 1 2 3 and 0 0 1 forms a basis of R cube if x is not equals to half. Clear? First, if you have a question from basis, first you have to check the coefficient determinant value. If coefficient determinant value is not equals to 0, that means your set of vectors is linearly independent. Number one. Number two, the number of vectors is, if it is 3, the dimension of R cube will be 3. Therefore, this set of vectors forms a basis. But in this problem, you don't know the actual value of x. Your x, when you consider the determinant value, that is the coefficient determinant, is equals to 0, so we get x equals to half. So from here it is clear, if we put x equals to half, the set of vector is linearly dependent vector. If x is not equals to half, then the set of vector is linearly independent, as well as it's form a basis. Clear? Next, another question. This is also very, very important question for you. If alpha, beta, gamma be a basis of vector space R cube, then show that alpha plus beta, beta plus gamma, and gamma plus alpha is also a basis set of R cube. Since alpha, beta, gamma forms a basis, so therefore alpha, beta, gamma is a linearly independent set of vectors. Okay. Now we equate any linear combination of alpha, beta, gamma with all null vector. Then the coefficient of alpha, beta, gamma must be equal to 0 by default. Must be equal to 0 because these are from the definition is clear. Now equating the linear combination. Of alpha plus beta, beta plus gamma, gamma plus with the null vector, then A alpha plus beta plus B, beta plus gamma plus C into gamma plus equals to null vector, that is theta. So A, B, C are scalar. So from here it is clear, you can write A plus C alpha, B plus C gamma plus C plus D gamma equals to null vector, B plus C gamma null vector. So if I can compare component wise, then is A plus C equal to 0, that is a coefficient, alpha coefficient 0, beta coefficient 0, C gamma coefficient 0. A plus C equals to 0, A plus B is equals to 0, A B plus C is equals to 0. Since alpha beta gamma are linearly independent, since already you know alpha beta gamma is a given information, so all scalar A B C all are 0. So solving this we can find A B C is also 0. So that means this is a linear combination of these three vector. So that means here all scalar are 0. So that means this set of vectors is linearly independent. Therefore alpha plus beta, beta plus gamma, gamma plus alpha forms a set of linearly independent set of vector. Further, since the set of vector alpha plus beta, beta plus gamma, and gamma plus alpha contains three linearly independent vectors, so dimension of R cube is equal to 3, as well as alpha plus beta, beta plus gamma, and gamma plus alpha forms a basis of R cube. Okay, so this type of question you can expect from here. Now, most interesting part, find a basis and dimension of a subspace R of R cube.